Welcome everyone. In this video I would like to show you quickly how to connect the TB6600 stepper motor controller to an Arduino circuit, and we will use this NEMA 17 stepper motor to demonstrate the connections. So just briefly about this stepper motor controller. You can see it has a huge heatsink, and it's packed in a relatively large box. For example, if you compare it with this easy driver stepper motor controller, then the difference in size is quite obvious. But of course the performance of the two devices are also very different. So what we have here, there is a table on this controller, as you can see. So by changing the switches, which can be found here, so these are small dip switches, you can change the micro stepping, so how much steps you will make within one turn, and it goes from 200 to 6400. And then you can also use some of the pins or switches to change the current on the output, and it starts from 0.5 amperes and it goes up to 3.5, and the peak current is a bit higher, so that is 0.7 to 4 amperes. And then you see that the switch number is defined here in these three columns, and then you can see how you should switch them. And then on this side you see the signal group of pins, and then you see this group of pins which are, or terminals, which are called high voltage. So the very simple is that the GND and the VCC is for the power supply, which should be between 9 and 42 volts. So that's what you have to use. And then A minus, A plus, and this is a coil basically. That's one coil from the stepper motor, so basically one pair of these wires. And B minus, B1 is the other pair of the wires for the stepper motor. And then you have 6 other connections for the signal connections. So this is ENA minus and ENA plus, and then you can see it in the parentheses that the ENA minus is ENA minus on the other side as well, and the ENA plus is plus 5 volt. And then you have the DIR minus and DIR plus, and pole minus and pole plus. So you have these 6 pins, and then you have these screw terminals, and also you have 2 LED lights here, so you can see if something happens here. So first of all, I would like to show you how to see which coil is which. It doesn't matter which is your B and which is your A. The only thing matters that you have to find the 2 coils. I cheated a little bit because I previously used this in several other videos, so I made them into pairs. But if you don't know, then you just take a multimeter and switch it to the mode where you can check the connections, so if something is connected or not. So I just changed that. So yes, it's this. So when I connect the 2 ends or the tips, then there is a beeping sound. So what you are looking for, and now I will be wrong on purpose, you take 2 wires from this, so connect to one end here, and then you take the other and connect it to the other end, and see, it's no connection. So these are not the same coil. So you take another, let's say we take the red, it's not beeping, so it's not the same coil. So you take the last one and it's giving sound. So it's the same coil. So you have these two. This belongs to one coil, and then of course you can exclude the two pins here, and then these two guys belong to the other coil. So then you can make these knots, for example, or loops, and you can distinguish the coils. So this is the very easy mode how to find. And how you connect it doesn't matter. The only thing which matters is that this should be one group which you found. So let's say this will be the B, and then this will be the other group. So to avoid any mess, first I just connect the motor to this controller. So this will be very easy. So let's start with this. So we connected the two coils of the motor. So in total 4 wires, and we remembered that this was one group, as you can see it on the loop there, and this was another group, as you can see on the loop. And for the ground and VCC connection, you can destroy one of the wires of your power supply, or just take a connection like this. And then when you use this, it's very simple. You should use some more thicker wires, but basically you know that one side is the plus, the other side is the minus. So what you do is just again connect it. So power supply and motor is connected. So now we go with the Arduino. And then that's very simple. So I took this breadboard just to make the things easy, because now comes the tricky part. So how you connect the TB6600 to the Arduino. So in the source code from my other videos, you could see that there are 2 pins basically which are used when you connect to this device by using the Arduino, and that is pin number 9 and pin number 8. And the 9 goes to the direction minus, and the pin 8 goes to the direction, to the pause minus. So basically 2 minus pins are connected to the Arduino directly. So first let's connect those. So I just take 2 wires, and then, as I said, so we need the direction minus, so that goes in. So it's fixed, and pulse minus is the other. So again, the direction minus goes to the number 9 here, and then the pause minus, that goes to the connection number 8. And then what happens to these others? So the enable A is not connected to anything, so you don't need to connect to anywhere, and you have 3 plus 5 volt connections. And what you do is very straightforward. As the text suggests, they should be connected to the plus 5 volt. So what we do here is we connect 3 wires to the corresponding places. So ENA plus 5, DIR plus 5, and POL plus 5. So let me just connect everything. So the plus 5 connections here, so ENA plus 5, DIR plus 5, and POL plus 5 has their own cables. So just for the demonstration, I took this breadboard, and you just make sure that they are connected to the same terminal. So you basically connect these 3 wires or 3 terminals together. And once you connected that together, you take another wire and connect it to the 5 volt output of the Arduino. So there is a 5 volt rail. You can find it between the 3.3 and the GND connections. and then you are done. So now this is done. So basically this is the connection in total. So once again, the enable A minus is not connected to anything, and then the plus connections of all the other functions, so enable A plus, direction plus, and pole plus is connected to the same 5-volt voltage. Of course, the 5-volt can come from something else than the Arduino, but it's so straightforward to use the Arduino. And then the minus dir and the minus pole is connected to the corresponding pins, which are defined in the source code, but if you want, I can tell. The direction pin is connected to the pin number 9, and pin number 8 is the pole. And you can use this with Arduino Mega or Arduino Nano or STM32 or whatever circuit driver or microcontroller you have. It's just the same. And then you have two groups of coils, because you have the two coils in the stepper motor. So you take one group and you find those by measuring them with the multimeter, and then you connect them, and that's all. And I suggest you, when you unpack your stepper motor for the first time, and if these wires are not in groups, then this is the best way to make them into groups, so you will never mess up the wiring. So you can make sure that the black and the green belongs together, and the red and the blue also belongs together, so they go to the same coil. And then you have the GND and the VCC, and that's very obvious. The GND is the ground, and the VCC is the plus 9 to 42 volts. So basically this is all, but in order to demonstrate that this circuit works, I will bring my laptop here and just quickly give a command and see if it works. So we will see it. So everything is wired up, and I now connected the computer. And just before proceeding to test the motor and the connections, I just want to mention the power supply which I use. So I recommend you to get something like this. It's a regulated power supply, and you can change the output voltage by changing the voltage here. And on this LCD screen you can also see the actual output voltage. And you can buy different ones. They are roughly 60 watts output. And this particular one is more than 70 watts, but it's small and compact, and you can use it for your projects. So I recommend you to get a few of these, because these are cheap and easy to use. So yeah, so there is some coloring on the top of this connection here, so I hope you can see that. But everything is connected, and I just use my laptop to send a command, and you can check the whole source code that I use in my previous video. So let's start with the motor. So I just make a few steps, and you will see what will happen. So you can see it works. It goes slowly. Just for fun, we can go a bit quicker. So you could see that you can accelerate this motor to quite high speeds, and it works very nicely. And what is exciting about this library, that the library takes care of the acceleration of the motor itself, so you don't have to recalculate the speed all the time, and that's very good, because it does the dirty job for you. So this was all basically. So I hope now you can connect the TB6600 to your stepper motor and to your Arduino easily. And by using the source code that I show in my previous videos in all its details, hopefully you will be able to build your own stepper motor based projects. But if you have any questions, just let me know in the comment section, and please just subscribe to support my work. So I hope you learned something, and see you in the next video.